Now we arrive at our first non-atomic object, lists. Lists are objects that contain elements of different types. They can contain elements of all the same type, but they do not have to. Whereas vectors, matrices, arrays, and factors are all atomic, that is, they contain the same data type, lists can contain different types of data. Lists can contain vectors, matrices, arrays, and even other lists. As with all the different types of objects that contain data that we are learning about in this learning cycle, we're going to learn much more about lists in a later learning cycle. But let's take a look at some simple characteristics of lists and functions we can use to create and work with lists. First, let's create a list. Here's a list that I'm calling Simple List. Look what it's going to contain. It's not going to contain all of the same type of data. We have South Carolina, which is a character, SC, which is a character, but then we have a number here, and another number here, and then another character. This wouldn't work if this was going to be a vector, but notice that I'm setting it up as a list with the list function. Let's see what it looks like. Before we actually look at each of the elements of that list, let's see how we can name each of those elements. We're going to use the names function. We're going to put simple list within the names function as an argument. And now we're going to attach to each one of these items in our list, we're going to attach a name. South Carolina is the state. The abbreviation is SC. Here's the population. Here's the square miles. And here's the capital. So let's go ahead and name those. And now let's look at what we have. Here is our list. State, abbreviation, population, square miles, and capital. Now each of these items in the list, in this case, is just one item, but it could be an entire vector. Now the vector, of course, would have to be atomic. So therefore, if I was going to say have a list of state names, I could put all the state names as one item in the list, but they would all have to be characters, which they would be. If I want to access any item in the list, I use the $sign to access that item. Notice the $sign before each of the names here in our list. So if I wanted to, for instance, look only at the square miles, I can use simple list square miles and actually get the square miles by accessing square miles, the name, using the $sign and simple list. Let's look at the class of simple list. Not surprising, it's a list. Now, what kind of data is simple list contain? It takes a little bit of a shortcut here. Instead of telling us each data type for each member of the list, it is just giving us list is the data type. Now, what if I was to say type of simple list and then access one of those like population? Now I can see what's actually in that one place in the list. So the type of data listed for the list as a whole is a list, but if I access any member of that list, I can actually see what type of data is in that list. Let's take a look at the attributes of this. The attributes are just names, and the names that we provided are listed here. Let's do another one. Here's a list in which I'm going to put the results of some analysis. I'm going to provide the point estimate, 10.5, the p-value, 0.0032, the decision that was made that it was statistically significant, and then a confidence interval that ranges from 8 to 13. Notice that this is a scalar, 10.5. The p-value is a scalar. The decision, statistically significant, is only one element in quotes, so it also is a character scalar or a single item in a character vector. But here we have a vector that contains more than one item, contains two items. So one item in the list, we are seeing here for the first time an example of one item in the list actually being a vector of multiple items. And that vector could be as long as we wanted it to be. So let's create that list, analysis results. Let's look at it. There it is. Notice the two items here for confidence interval. Let's access that separately. Analysis results confidence interval, and there are the two items in the vector. Again, we could have 4, 5, 100 items in a vector as one element of our list.